What if we told you that everything you see, touch, and experience began with a single, unimaginable explosion of energy and matter? The Big Bang Theory isn't just a theory. It's the story of how our universe came to life, from a tiny, infinitely dense point to the vast cosmos we marvel at today. How did this incredible journey begin, and what clues reveal our cosmic origins? Join us as we explore the birth of the universe, the forces shaping it, and what lies ahead in its vast, mysterious future. The Big Bang, the beginning of everything. The universe as we know it started approximately 13.8 billion years ago with an event known as the Big Bang. Far from being an explosion in space, the Big Bang was an expansion of space itself from a singularity, an infinitely small, dense, and hot point. In that fraction of a second, the laws of physics as we understand them came into existence, creating the foundation for everything in the cosmos. Within the first second, the universe expanded rapidly, a phenomenon called cosmic inflation. During this time, temperatures reached unimaginable levels, allowing the formation of the fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces. These forces govern the behavior of all matter and energy, making them the building blocks of the universe's structure. As the universe cooled, the first particles began to form. Quarks and electrons emerged, eventually combining to create protons and neutrons. These, in turn, formed the nuclei of the first atoms. Light particles, or photons, were released, marking the beginning of the universe's transition from opaque to transparent, a moment captured in the cosmic microwave background radiation that scientists study today. The Big Bang Theory is supported by compelling evidence. The observed expansion of the universe, first noted by Edwin Hubble, aligns perfectly with the idea that space itself has been stretching since the Big Bang. The discovery of cosmic microwave background radiation, a faint glow left over from the event, provides a snapshot of the universe when it was just 380,000 years old, offering a direct look at its earliest moments. Understanding the Big Bang is not just about looking into the past. It's about understanding how everything we see, from galaxies to the atoms in our bodies, came into being. It is the ultimate story of creation, a narrative that continues to inspire humanity's quest for knowledge. Cosmic inflation, the rapid expansion. The concept of cosmic inflation is one of the most fascinating aspects of the Big Bang Theory. In less than a trillionth of a second, the universe expanded exponentially, growing from a size smaller than an atom to that of a grapefruit. This rapid expansion set the stage for the universe's large-scale structure and explains many of its current properties. During inflation, tiny quantum fluctuations in the fabric of space were stretched to cosmic proportions. These fluctuations became the seeds of galaxies, clusters, and voids that would form millions of years later. It's mind-blowing to think that the intricate structures of the universe originated from minuscule variations in energy. Inflation also accounts for the universe's uniformity. Despite its vastness, the universe appears remarkably consistent in all directions. This homogeneity would be impossible without inflation, as it ensured that all regions of the universe were once close enough to share energy and information. Another key prediction of inflation is the formation of the cosmic microwave background radiation. As the universe expanded and cooled, light particles were able to travel freely for the first time, creating a snapshot of the universe in its infancy. This relic radiation provides critical evidence supporting the theory of inflation, showing subtle variations that align with the expected quantum fluctuations. While the idea of inflation is widely accepted, questions remain. What caused inflation to start and stop? And what happened to the energy released during this process? These mysteries keep scientists pushing the boundaries of our understanding, seeking answers that could reshape our view of the cosmos. Formation of matter building the universe's foundations. In the seconds and minutes following the Big Bang, the universe was a seething soup of particles. Protons and neutrons formed from quarks, and as the universe cooled, these particles combined to create the first atomic nuclei in a process known as nucleosynthesis. This critical period laid the groundwork for the chemical elements that would later form stars, planets, and life. The most abundant elements created during this time were hydrogen and helium, along with trace amounts of lithium and beryllium. These light elements make up most of the universe's observable matter today. Heavier elements, such as carbon and oxygen, wouldn't appear until much later, forged in the cores of stars. The distribution of these elements is remarkably uniform, a testament to the Big Bang's influence. Scientists measure this distribution using spectroscopy, comparing observations to theoretical predictions. The match between observed and predicted abundances is one of the strongest pieces of evidence for the Big Bang theory. As the universe expanded further, gravity began to take hold. Tiny variations in the density of matter caused particles to clump together, forming the seeds of galaxies and clusters. These clumps grew larger over millions of years, eventually creating the cosmic web of structures we see today. The story of matter's formation is one of transformation, from a chaotic high-energy state to the intricate structures that define the universe. It's a reminder of how complexity arises from simplicity, a theme that resonates across science and nature. The cosmic microwave background, a glimpse into the past. The cosmic microwave background, or CMB, is often called the baby picture of the universe. Discovered in 1964 by Arno Penzias and Robert Wilson, the CMB is a faint glow of radiation that permeates the universe, providing a direct link to the Big Bang. This radiation was released approximately 380,000 years after the Big Bang, when the universe had cooled enough for atoms to form. Before this time, the universe was an opaque plasma, where light could not travel freely. The formation of neutral atoms allowed light to escape, creating the CMB we observe today. The CMB is not uniform. It contains tiny temperature fluctuations that reflect differences in the density of matter in the early universe. These fluctuations are the fingerprints of the initial quantum variations that were stretched during inflation. By studying the CMB, scientists can reconstruct the universe's history and refine their models of cosmic evolution. Modern telescopes, such as the Planck satellite, have mapped the CMB in incredible detail, revealing a wealth of information about the universe's composition, age, and shape. The data confirms that ordinary matter, and dark energy make up the universe, with the latter driving its accelerated expansion. The study of the CMB is a prime example of how scientific discovery builds on itself. From an accidental finding to a cornerstone of cosmology, the CMB continues to deepen our understanding of the universe's origins and its future. The evolution of galaxies from chaos to cosmic cities. Galaxies, the cosmic cities of stars, emerged from the aftermath of the Big Bang. They began forming roughly 100 million years after the universe's birth, as gravity worked on tiny fluctuations in the density of matter. These small irregularities, visible in the cosmic microwave background, grew over time into dense regions that became the cradles of galaxy formation. Initially, these protogalaxies were turbulent and chaotic, composed of gas clouds and newly forming stars. Over billions of years, they evolved into the diverse structures we see today, from spiral galaxies like the Milky Way to massive elliptical galaxies and irregular systems. This evolution was shaped by processes such as star formation, supernova explosions, and interactions between galaxies, including mergers and collisions. Galactic collisions played a significant role in shaping the universe. When galaxies merged, their shapes were altered, their star formation rates increased, and central supermassive black holes grew. The Milky Way, for example, is the result of countless mergers over billions of years, and it continues to interact with its neighbors, including the Andromeda Galaxy, which it will collide with in about 4.5 billion years. The formation of galaxies was also influenced by dark matter, an invisible substance that makes up about 27% of the universe. Dark matter provided the gravitational scaffolding necessary for galaxies to form and hold together. Without it, the visible matter we observe in the form of stars and gas would have dispersed rather than coalesced into galaxies. Galaxies are not just collections of stars, they are laboratories where the universe's history and future unfold. By studying them, scientists uncover clues about the conditions that shaped the cosmos and gain insights into the forces that continue to influence its evolution. The role of dark matter, the invisible hand of the cosmos. Dark matter is one of the universe's most enigmatic components. Although it doesn't emit, absorb, or reflect light, its presence is felt through its gravitational influence. It acts as the invisible scaffolding that holds galaxies and galaxy clusters together, playing a crucial role in the large-scale structure of the universe. Evidence for dark matter first emerged in the 1930s when astronomer Fritz Zwicky observed that galaxies in the Coma cluster were moving too quickly to be held together by visible matter alone. Later studies, including those of spiral galaxies by Vera Rubin, confirmed that the outer stars in galaxies orbit at unexpectedly high speeds, suggesting the presence of unseen mass. Dark matter is thought to form massive halos around galaxies, providing the gravitational pull necessary to maintain their structure. Without it, galaxies would not have enough mass to prevent their stars from drifting apart. This unseen material also helped amplify the density fluctuations in the early universe, enabling the formation of galaxies and clusters. Although dark matter's nature remains unknown, scientists have proposed various candidates, including weakly interacting massive particles or WIMPs and axions. Experiments on Earth, such as those conducted in underground laboratories and particle accelerators, aim to detect these elusive particles, while observations of cosmic phenomena provide indirect evidence. Dark matter's influence extends beyond galaxies. It shapes the cosmic web, a vast network of filaments and voids that define the large-scale structure of the universe. Understanding dark matter is key to solving many of cosmology's greatest mysteries and unlocking the secrets of the universe's formation and evolution. The ultimate fate of the universe, a journey into the unknown. The universe's fate is a question as profound as its origins. While the Big Bang marked the beginning of time and space, the cosmos is far from static. It is expanding, a fact first discovered by Edwin Hubble. The nature of this expansion holds the key to the universe's ultimate destiny. For much of the 20th century, scientists debated whether the universe would expand forever, slow down, or reverse in a big crunch. However, in 1998, observations of distant supernovae revealed that the expansion of the universe is accelerating, driven by a mysterious force known as dark energy. Dark energy, which constitutes about 68% of the universe, is the dominant factor shaping its future. If dark energy remains constant, the universe will continue expanding indefinitely, leading to a scenario called the Big Freeze. In this future, galaxies will drift farther apart, stars will exhaust their fuel, and the cosmos will grow cold and dark as entropy increases. Alternatively, if dark energy intensifies over time, it could tear apart galaxies, stars, and even atoms in a dramatic end known as the Big Rip. Another possibility is the Big Bounce, in which the universe's expansion eventually halts and reverses, leading to a new Big Bang. This theory suggests a cyclical universe with endless cycles of creation and destruction. Although less widely accepted, it raises intriguing questions about the nature of time and the potential for new beginnings. The ultimate fate of the universe remains uncertain, but each theory offers a glimpse into the vast possibilities of cosmic evolution. As scientists refine their understanding of dark energy and other cosmic forces, we move closer to unraveling the final chapter of the universe's story. The universe as a cosmic laboratory, a quest for understanding. The universe is more than a collection of stars, galaxies, and cosmic phenomena. It is a vast laboratory where the laws of nature are constantly tested. Every corner of the cosmos offers clues about its origins, evolution, and the fundamental principles that govern reality. From the tiniest particles to the largest galaxy clusters, the universe operates on a set of rules that scientists strive to decode. The interplay of forces like gravity, electromagnetism, and nuclear interactions shapes everything from the structure of atoms to the motion of galaxies. Understanding these forces provides a deeper appreciation of the universe's complexity and beauty. Telescopes and observatories, such as the Hubble Space Telescope and the upcoming James Webb Space Telescope, have revolutionized our view of the cosmos. They allow us to peer into the universe's distant past, observing light that has traveled billions of years to reach us. These observations provide a timeline of cosmic evolution, from the birth of the first stars to the formation of galaxies and beyond. Advances in technology have also enabled scientists to simulate the universe's evolution on supercomputers, recreating conditions from the Big Bang to the present day. These simulations help researchers test theories, predict cosmic phenomena, and understand the universe's large-scale structure. The universe is a living story, with each discovery adding a new chapter. As we continue to explore, we not only uncover the secrets of the cosmos, but also deepen our connection to the vast, intricate tapestry of existence. The story of the universe is as infinite as the cosmos itself, filled with mysteries, wonders, and profound questions. From the Big Bang to the distant future, every discovery reminds us of the incredible journey we are part of. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep reaching for the stars and discovering the endless wonders of the universe. Have you ever wondered what strange secrets our solar system holds? From bizarre storms that rage for centuries to moons with hidden oceans, our cosmic backyard is filled with mysteries that defy explanation. What if I told you some of these phenomena could reshape our understanding of the universe? Join us as we explore the top 10 strangest phenomena in our solar system, uncovering the wonders and enigmas that make our celestial neighborhood so extraordinary. Jupiter's Great Red Spot. A swirling crimson storm on Jupiter, larger than Earth, has raged for over 350 years. This massive anticyclonic storm is one of the most iconic features of our solar system. Scientists believe the red color might come from complex organic molecules formed under intense UV radiation, but no one knows for sure. The Great Red Spot's winds reach speeds of over 400 miles per hour, making it more violent than any hurricane on Earth. It's shrinking over time, leaving researchers puzzled about its ultimate fate. Could it disappear entirely or transform into something new? What's truly fascinating is how deep this storm goes. Recent data from NASA's Juno spacecraft suggests the storm extends hundreds of miles into Jupiter's atmosphere. This depth gives scientists a glimpse into the planet's mysterious weather patterns. The storm's longevity is another enigma. While storms on Earth last days or weeks, Jupiter's atmosphere lacks a solid surface, allowing storms like this to persist for centuries. But the mechanics of its formation and endurance remain elusive. Jupiter's Great Red Spot isn't just a storm. It's a window into the planet's chaotic and extreme atmospheric dynamics. Understanding it might help unravel mysteries about weather patterns on gas giants and beyond. Saturn's hexagonal storm. Saturn's North Pole boasts a geometric wonder, a perfectly shaped hexagonal storm system. Unlike anything seen on Earth, this six-sided jet stream spans about 20,000 miles across. Its symmetry leaves scientists scratching their heads. The hexagon structure likely forms due to fluid dynamics, where different wind speeds create a stable, standing wave. But why it takes this precise hexagonal shape instead of a circular one remains a mystery. Images from the Cassini spacecraft revealed the storm's depth and color changes over Saturn's seasons. This dynamic evolution adds another layer of complexity to its already puzzling nature. Beneath the hexagon lies a massive hurricane-like storm with an eye and spiraling arms, adding to the polar region's bizarre and chaotic weather. These layers of storms might hold clues to the gas giant's atmospheric mechanics. Saturn's hexagonal storm isn't just a strange shape, it's a planetary phenomenon that challenges our understanding of weather and fluid mechanics. It reminds us how alien the weather on other planets can truly be. Uranus's tilt. Uranus spins on its side with an axial tilt of 98 degrees. This means it essentially rolls around the sun like a barrel. No other planet in the solar system behaves this way, making Uranus a true oddball. The tilt likely resulted from a massive collision early in the planet's history. A protoplanet or giant object could have struck Uranus, knocking it over. But the details of this ancient event remain speculative. This unusual orientation creates extreme seasons. One pole experiences 42 years of sunlight, followed by 42 years of darkness. The planet's atmosphere also features high-speed winds and faint rings, all aligned with its peculiar axis. Another mystery is Uranus's magnetic field. Unlike Earth's relatively aligned magnetic and rotational axes, Uranus's magnetic field is wildly skewed, further emphasizing its chaotic nature. Uranus's tilt isn't just a quirk, it's a reminder of the violent events that shaped our solar system. Understanding its unique orientation could provide insights into planetary formation and evolution. Venus's runaway greenhouse effect. Venus, often called Earth's twin, offers a cautionary tale of a climate gone wild. With a surface temperature hot enough to melt lead, Venus's atmosphere is dominated by carbon dioxide, trapping heat in a runaway greenhouse effect. Scientists believe Venus may have once had oceans and a more Earth-like climate, but volcanic activity released massive amounts of CO2, causing temperatures to spiral out of control. Now its surface is a scorching wasteland. The thick atmosphere also leads to crushing pressure, about 92 times that of Earth. Spacecraft that have landed on Venus survive mere hours before succumbing to the heat and pressure. Adding to the mystery are Venus's clouds, which contain sulfuric acid. These clouds reflect sunlight, making Venus appear bright from Earth, yet they also obscure its surface from direct observation. Venus's extreme environment provides a stark contrast to Earth and serves as a warning of how delicate planetary climates can be. Neptune's supersonic winds. On the distant icy world of Neptune, winds rage at speeds exceeding 1,200 miles per hour, faster than the speed of sound on Earth. Despite being far from the sun and incredibly cold, Neptune's atmosphere is shockingly dynamic. These supersonic winds likely arise from the planet's internal heat. Neptune radiates more energy than it receives from the sun, fueling its turbulent weather. One of Neptune's most iconic features, the Great Dark Spot, is a massive storm similar to Jupiter's Great Red Spot. Though it's transient, appearing and disappearing over the years, it showcases the power of Neptune's atmosphere. The planet's deep blue color comes from methane in its atmosphere, which absorbs red light. But why Neptune's weather is so extreme remains unclear. Neptune challenges our assumptions about planetary weather, showing that even cold, distant worlds can harbor violent, energetic storms. Mars's dust storms. Mars experiences planet-wide dust storms that can last for months and cover the entire planet. These storms are the largest in the solar system and have even grounded rovers like Opportunity. Dust storms on Mars are driven by solar heating, which causes atmospheric pressure differences and creates strong winds. These winds lift fine dust particles into the air, creating massive swirling clouds. The thin atmosphere means these storms aren't very strong in terms of force, but they're incredibly widespread. The fine dust can block sunlight, plunging the planet into darkness and drastically affecting temperatures. The storms also play a role in shaping Mars's surface. Dust settles into dunes and patterns that reflect the planet's dynamic weather. Understanding these storms is crucial for future human missions to Mars. They highlight the challenges of living and working on a planet so different from our own. Mercury's shrinking planet. Mercury, the smallest planet in our solar system, is gradually shrinking. Evidence from NASA's Messenger spacecraft revealed that Mercury's surface is covered with massive cliffs, or lobate scarps, that formed as the planet's interior cooled and contracted. This shrinkage is caused by the planet's metallic core losing heat over billions of years. As the core contracts, the outer crust crumples, creating cliffs that can reach over a mile high and hundreds of miles long. Unlike tectonic plates on Earth, Mercury's crust is a single shell, which wrinkles as it compresses. What's fascinating is the planet's ongoing geological activity. Scientists believe Mercury is still contracting today, making it a dynamic world despite its small size and proximity to the Sun. This process also affects Mercury's magnetic field, which is weaker than Earth's. The cooling and shrinking of its core likely play a role in the mysterious offset of its magnetic field from the planet's center. Mercury's shrinking serves as a reminder that even the smallest planets are not static. Understanding this phenomenon provides insights into how rocky planets evolve and change over time. The Singing Comet, 67P Comet. 67P/Churyumov-Gerasimenko, explored by the Rosetta spacecraft, stunned scientists when it was found to sing. The comet emits a strange rhythmic sound, an oscillating magnetic field generated by charged particles interacting with its surface. This haunting sound is far below the range of human hearing, but was amplified by scientists to reveal its eerie melody. The exact mechanism behind the singing remains unclear, adding an air of mystery to this icy traveler. Comet 67P's unique shape, resembling a rubber duck, adds to its intrigue. This odd form likely resulted from the collision and fusion of two smaller comets billions of years ago, giving it a distinctive profile, unlike anything else in the solar system. As the comet approaches the Sun, its frozen gases vaporize, creating jets of gas and dust that stream into space. These interactions might amplify the singing effect, revealing the comet's dynamic and ever-changing nature. Comet 67P is a window into the early solar system, offering clues about how planets formed. Its song is a cosmic soundtrack that reminds us how alive the universe truly is. Pluto's frozen heart. Pluto, once considered the ninth planet, boasts a striking feature, a heart-shaped glacier called Tombaugh Regio. This icy plain is made of nitrogen, carbon monoxide, and methane ice, and it defies expectations by showing signs of geological activity. Despite being billions of miles from the Sun, Pluto's heart is a dynamic region. The ice appears to flow like glaciers on Earth, reshaping the surface over time. The heat driving this movement likely comes from radioactive decay in Pluto's core, but scientists are still unraveling the exact mechanisms. Tombaugh Regio's left lobe, Sputnik Planitia, sits in a massive impact basin. The basin's location is thought to stabilize Pluto's spin, and its reflective ice plays a role in the planet's climate by affecting how heat is distributed. New Horizons flyby also revealed strange polygonal patterns on the glacier, likely caused by convection currents beneath the surface. These patterns indicate a planet that, despite its distance and cold, remains surprisingly active. Pluto's heart symbolizes more than geological activity. It's a reminder that even the smallest, coldest worlds can hold extraordinary secrets. Enceladus's cryovolcanoes. Saturn's moon. Enceladus hides a global ocean beneath its icy crust. Its surface is marked by dramatic cryovolcanoes that spew water vapor, ice, and organic compounds into space. These plumes, discovered by the Cassini spacecraft, are among the most exciting phenomena in the solar system. The source of these cryovolcanoes lies deep within Enceladus. Tidal forces from Saturn stretch and compress the moon, generating heat in its core. This heat melts ice into water, which escapes through cracks in the surface as geysers. Scientists are particularly intrigued by the discovery of organic molecules in these plumes. Combined with the presence of liquid water and internal heat, Enceladus is considered one of the best places to search for extraterrestrial life. The plumes even create Saturn's faint E-ring, spreading tiny ice particles into orbit around the planet. This dynamic relationship between the moon and the planet showcases the interconnected nature of celestial bodies. Enceladus's cryovolcanoes represent more than geological activity. They're a glimpse into the possibility of life beyond Earth. As one of the most captivating destinations in our solar system, this icy moon holds mysteries waiting to be explored. Our journey through the solar system's strangest phenomena shows just how diverse and mysterious our cosmic neighborhood truly is. From icy moons and singing comets to shrinking planets and hexagonal storms, these wonders remind us of the universe's endless surprises. If you enjoyed this adventure, be sure to like, share, and subscribe to InnoVision Tech. Hit the bell icon so you never miss our latest explorations. Until next time, keep exploring the cosmos with us. Have you ever wondered about the most breathtaking wonders hidden within the Milky Way galaxy? From ancient stars to colossal stellar giants, our galactic home is full of marvels that defy imagination. What secrets does the Milky Way hold? And how do these celestial wonders shape the universe we live in? Join us as we uncover 7 of the most extraordinary wonders of the Milky Way galaxy, taking you on a mesmerizing journey through space and time. The Sagittarius Stream. Stretching like a ribbon across the vast expanse of the Milky Way, the Sagittarius Stream is a stunning example of cosmic dynamics at play. This incredible structure is a stellar stream composed of stars that were once part of the Sagittarius dwarf galaxy. Over billions of years, gravitational forces pulled the dwarf galaxy apart, leaving behind a trail of stars that now orbits the Milky Way in a spectacular arc. What makes the Sagittarius Stream so fascinating is its significance in understanding the history of galaxy formation. As the stars in the stream move around the Milky Way, they reveal clues about how our galaxy interacts with smaller satellite galaxies. Scientists study their distribution, speed, and composition to better understand the gravitational forces at play. The Sagittarius Stream is also a key piece in the puzzle of galactic cannibalism, a process where larger galaxies consume smaller ones. Observing this stream has helped astronomers confirm that the Milky Way has grown by merging with smaller galaxies over time. This discovery reshapes how we view our galactic history. Additionally, the stars in the Sagittarius stream provide valuable insight into the chemical makeup of older galaxies. Many of these stars are rich in heavy elements, indicating that the Sagittarius dwarf galaxy underwent multiple generations of star formation before its integration into the Milky Way. The sheer scale of this structure is awe-inspiring, spanning nearly a third of the sky as seen from Earth. Its ethereal beauty and scientific importance make the Sagittarius stream one of the true wonders of our galaxy, a testament to the ever-evolving nature of the cosmos. The Pillars of Creation. Deep within the Eagle Nebula, approximately 7,000 light-years from Earth, lies one of the most iconic sights in astronomy, the Pillars of Creation. These towering columns of gas and dust stretch several light-years high, resembling massive celestial sculptures. Yet these pillars are not static, they are active nurseries where new stars are born. The Pillars of Creation were made famous by the Hubble Space Telescope, which captured their majestic beauty in 1995. These towering structures are composed primarily of hydrogen gas, with dense regions collapsing under their own gravity to form new stars. The surrounding ultraviolet radiation from nearby massive stars sculpts and illuminates the pillars, giving them their striking appearance. Beyond their visual appeal, the Pillars of Creation are a rich source of scientific discovery. They offer a window into the complex processes of star formation. By studying the pillars, astronomers can better understand the life cycle of stars and the intricate interplay of forces that shape their birth and evolution. Interestingly, the Pillars of Creation may no longer exist as we see them today. Because light from this region takes thousands of years to reach us, it's possible that a supernova explosion has already destroyed the pillars. However, their image remains a powerful symbol of the ever-changing universe. These pillars are a reminder of the creative forces that drive the cosmos, illustrating the birth of new celestial objects amid the vast expanse of space. Their beauty and significance earn them a place among the Milky Way's most extraordinary wonders. VY Canis Majoris. On the grand stage of the Milky Way, VY Canis Majoris takes center stage as one of the largest stars ever discovered. This red hypergiant, located in the constellation Canis Major, is so massive that if placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. VY Canis Majoris is nearing the end of its stellar life, and its enormous size is a prelude to its eventual fate, a supernova explosion. This star has already shed a significant portion of its mass, creating a surrounding nebula of gas and dust. Observing this phenomenon helps astronomers understand the final stages of massive star evolution. What sets VY Canis Majoris apart is its unpredictability. Its surface is constantly in flux, with gigantic eruptions of material creating a chaotic and turbulent environment. These eruptions give scientists a glimpse into the complex processes occurring within the cores of massive stars. This colossal star is also a critical benchmark for understanding the upper limits of stellar sizes. Its existence challenges traditional models of star formation and raises questions about the lifespan and behavior of hypergiants. Despite its distance from Earth, roughly 4,000 light-years, VY Canis Majoris inspires awe with its sheer scale and luminosity. It is a vivid reminder of the extremes that exist in our galaxy and a symbol of the incredible diversity of celestial phenomena. SIMS J03130.36-67839.3. Known as SM0313, this unassuming star holds a remarkable secret. It is one of the oldest stars ever discovered. Estimated to be over 13.6 billion years old, SM0313 formed just a few hundred million years after the Big Bang, making it a living fossil of the early universe. Located approximately 6,000 light-years from Earth, SM0313 has a composition that sets it apart from younger stars. It lacks heavy elements like iron, which are typically produced in the cores of stars and dispersed through supernova explosions. Instead, it is made almost entirely of hydrogen and helium, the primordial elements of the cosmos. Studying SM0313 provides scientists with a rare glimpse into the conditions of the early universe. Its existence confirms that the first stars formed shortly after the Big Bang, helping to seed the cosmos with the elements necessary for planets and life. This ancient star also challenges existing theories of star formation. Its low metallicity suggests that it formed in an environment with minimal chemical enrichment, a scenario that defies conventional models. Observing such a star opens new avenues for understanding how the earliest stars came into being. As a relic of the universe's infancy, SM0313 is a treasure trove of information. It stands as a testament to the enduring nature of stars and the vast timeline of cosmic history, earning its place among the Milky Way's greatest wonders. The Great Carina Nebula. Among the Milky Way's many stunning sights, the Great Carina Nebula stands out as a magnificent tapestry of stars, gas, and dust. Situated about 8,500 light-years from Earth in the constellation Carina, this vast nebula is one of the most active star-forming regions in our galaxy. Its immense size and brilliant displays make it a natural wonder of cosmic artistry. The Carina Nebula is home to some of the most massive and luminous stars known to science, including the enigmatic Eta Carinae. This massive binary star system is on the verge of a cataclysmic supernova explosion. Observing Eta Carinae and its surrounding nebula offers astronomers invaluable insights into the life cycles of the universe's most powerful stars. What sets the Carina Nebula apart is its remarkable diversity of celestial phenomena. Within its boundaries are towering pillars of gas, intricate filaments of dust, and newly formed stars. These structures are shaped by intense stellar winds and radiation, creating a dynamic environment that reflects the ongoing processes of star formation and destruction. Recent observations, including those from the James Webb Space Telescope, have revealed hidden details of the nebula's structure. By peering through dense clouds of dust, astronomers can witness the birth of stars and planetary systems, offering a glimpse into the origins of our own solar system. The sheer scale and beauty of the Carina Nebula make it a standout feature of the Milky Way. Stretching over 300 light-years, it is a cosmic masterpiece that embodies the creativity and chaos of the universe. Its glowing clouds and dynamic activity capture the imagination, earning it a place among the galaxy's most extraordinary wonders. The Fermi Bubbles. Towering above and below the Milky Way's central plane are the mysterious Fermi Bubbles, two massive lobes of high-energy gas stretching 25,000 light-years each. Discovered in 2010 by the Fermi Gamma Ray Space Telescope, these enigmatic structures are among the most puzzling phenomena in our galaxy. The origin of the Fermi Bubbles is a subject of ongoing research. Scientists believe they were created by a powerful event at the galaxy's core, likely involving the supermassive black hole known as Sagittarius A*. This event may have been the result of a past outburst of activity such as the accretion of large amounts of matter or a burst of star formation. The Fermi Bubbles are a treasure trove of data for astrophysicists. They emit high-energy gamma rays, providing clues about the extreme processes occurring in the heart of our galaxy. The edges of the bubbles are also sites of intense interaction between cosmic rays and interstellar gas, revealing the dynamic interplay of forces shaping the Milky Way. One of the most intriguing aspects of the Fermi Bubbles is their symmetry. Their nearly identical shape and size suggest a single dramatic origin event. Studying these structures helps scientists refine models of galactic evolution and understand the long-term effects of energetic phenomena on a galaxy's environment. These colossal bubbles are a testament to the immense power of the Milky Way's core. Their discovery has opened new doors to understanding the past activities of our galaxy, making them one of its most awe-inspiring and mysterious wonders. The galactic halo. Encircling the visible disk of the Milky Way is the galactic halo, a vast, nearly invisible region that contains some of the oldest stars in the galaxy. Stretching tens of thousands of light-years above and below the galactic plane, the halo is a faint, enigmatic structure that holds the secrets of our galaxy's earliest days. The galactic halo is populated by ancient stars and globular clusters, dense groups of stars that orbit the Milky Way. Many of these stars formed more than 10 billion years ago, making them relics of the early universe. Their unique chemical compositions provide critical clues about the conditions that existed shortly after the Big Bang. What makes the halo particularly fascinating is its dark matter component. Scientists estimate that the majority of the halo's mass is composed of dark matter, an invisible substance that does not emit or absorb light, but exerts a gravitational influence. The halo's dark matter is crucial for understanding the Milky Way's structure and its rotation. Exploring the galactic halo also sheds light on the Milky Way's interactions with its surroundings. This region contains streams of stars torn from smaller galaxies that were absorbed by the Milky Way over billions of years. These stellar streams act as cosmic fossils, revealing the galaxy's history of growth through mergers and acquisitions. Though largely hidden from view, the galactic halo is an essential part of the Milky Way's identity. It connects the visible galaxy to the vast, unseen forces that shape the cosmos. Its mysteries continue to inspire astronomers, solidifying its place among the wonders of our galaxy. From towering star nurseries to colossal cosmic structures, the wonders of the Milky Way are as breathtaking as they are mysterious. Each reveals a unique story about the universe we call home. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the cosmos with us.